Okay, video number 5, and I'm on the timer. Now, first of all, if you've noticed something's changed, my head, I went ahead and did my occasional head shaving. Feel much better now. Getting a little lazy over the summer, so my previous videos had me with a little more hair. So I'm looking fresher today. Okay, video number 5. Now for this video, we are going to pick up with a repeat example from the prior video. And this is where we're going to say, just to review this, and then we're going to give you the shortcut method that I really want you to use when you're doing work for me. You have 3.3 kilograms and you want to convert it to ounces. Now, again, if you happen to know the ounce to kilogram conversion off the top of your head, you could go ahead and whip this thing out in one step, but most people probably won't do that or be able to know that off the top of their head. So what we're going to do here is we're going to do this approach where we're going to go from kilograms to grams and then grams to ounces. And so if we start here in step 1, what we would have to say is, I need to get from kilograms to grams, so I need X grams, and I'm starting with 3.3 kilograms, and that is going to be equal to my conversion factor between grams and kilograms. Now, in order to establish this one here, this is where we would go back to the metric prefix information that we gave you, I forget if it was in video 2 or video 3, where we'd say, look, I need a relationship between gram and kilogram. The way I would approach this is, remember that kilo has a multiplier of +3, and gram, because it does not have a prefix, would be at 0. So between these two, the way I do this is, kilogram is bigger, so it would get 1, and that means the other unit would get my capital E, which remember represents a base 10, and then the separation between these two values here that I have is 3. So in order to hammer out how many grams does this all represent, I would have to multiply by 3.3 kilograms, and then I'm going to bring this down here and use my commutative property so I can just reverse their order. Put 3.3 kilograms, and I'm going to give this guy here the parentheses, and we'll have E3 grams over 1 kilogram. So that would be my answer here, and I could stop and go ahead and calculate this, but I'm not going to do that for a particular reason. So now this represents how many grams I have, so this would be the first step, and I'll call this number 1. So this work here, number 2, is number 1. And then for number 2, I have to go from gram to ounces. So that means what I would want to know is a certain number of ounces, and then my starting value for grams would be this 3.3 kilograms times E3 grams over 1 kilogram. And on the opposite side, I would need my conversion factor between ounces and grams, because remember, these kilograms here as units would have canceled, so this value here, complete my parentheses properly, really represents a certain number of grams. Now my relationship here, this is one of those that I told you you would have to memorize because it's a metric English equivalent. 1 ounce is 28.4 grams. So in order to end up solving for this, I would multiply this thing by my 3.3 kilograms times E3 grams over 1 kilogram. And then I'd have to duplicate that over here. 3.3 kilograms times E3 grams over 1 kilogram. and then these things here would all cancel, and I'd be left with X ounces. And over here, if I rearrange this, the way it will look more like what we want when we go through the shortcut method, I'm going to put the 3.3 kilograms first, and then I'll have my E3 grams over 1 kilogram. And then what I have here, if I put these in parentheses, is I have 1 ounce over 28.4 grams. So if we look at the units in our setup here, the kilograms would cancel, the grams would cancel, and that leaves us with our ounces. So in terms of what math does this tell us to do, it tells us to start with the number 3.3, and then because we have E3, which remember is 10 to the third, over 1, that means we would multiply by E3. And I leave the E there because, again, most calculators that I'm aware of are starting to use this notation. And it really, I think, helps make some of the calculations a little quicker to get through if you take advantage of that. And then when we look at the last conversion factor, we have 1 over 28.4, which really just means divide by 28.4. So if we go ahead and do that, 3.3 times E3 divided by 28.4, then what this translates to is our X ounces really is a value of 1.162 E2. I tend to leave my calculator in scientific notation, and then the unit on this would just be ounces. Okay, now this methodology here, very, very time consuming. And if, for example, if you had to do a conversion where you looked at all of the sub conversions you needed to do and you said, oh my God, I got to do like 3 steps because I don't know enough information to go directly from one to the other, this approach could just become overwhelming. But the thing that I want to highlight is in our final structure, one of the things that our last example and this one both shared was that when you look at the units, they were always diagonal from each other. And that is a principle that we are going to build off of here. And some people call this the factor label method. Some people, when you see the physical structure, refer to this as the railroad method, and you've probably been exposed to that from your prior chemistry class. I have my own way of approaching this. I call it the magic H. So what I'm going to do now is I'm going to take you through a couple examples and explain to you what it is I want to see when I give you one of these problems. And again, I'm going to remind you, at least for the first semester, and maybe a decent amount into the second semester, I am going to be giving you, one type of, one problem that is like this, just a unit conversion problem. They all won't be this simple, but the idea is that I will grade this very, very meticulously. And part of that grade is going to be in the setup that you put on that piece of paper. Because this setup here is what tells you what math you need to do. And down the road, when you're like, I'm sick of this, I've done it so often, and you just do stuff in your head, or you write things down minimally on a piece of paper, I'm going to leave that for down the road. For right now, I am going to demand that you write down all of your procedures so I can see the structure that leads you to the math to hopefully get the right answer. So, here is where I am going to direct you to a worksheet on the class webpage. Remember, it is bit.ly Physics NG. And if you go to the home page and click on Honors Physics, you'll see conversion worksheets. And one of the worksheets that's listed there has the title of Level 1. and I have it opened on my laptop here. So I am going to be choosing one of these problems to kind of give you the, I'm going to call it the shortcut way of doing these conversions. And on this worksheet, there are 10 problems. Okay, so I am going to start, let's go with, what's a good one? Okay, I'm going to start with number 6. Okay, and I'm going to walk you through 2 of these, and hopefully this will be enough so that I can say, you should do the other 8. Make sure you can get the right answers to these, and if so, you're in a good place, because we do have more to do, but these are as simple as they go. And just so you're aware with my references here, the way I look at the unit conversions that we're going to be doing, there are a total of, I think, 4 different levels of difficulty. Level 1 is the simplest. All we are going to be doing is converting 1 unit of length, mass, time, or volume to another unit of length, mass, time, or volume, and that's it. But units can get more complex than that, and that's where we get into the level 2, level 3, level 4, and I'm going to leave those for future lectures here. Okay, so problem number 6, this is what it looks like. 6.74 E2, then you see this thing, and then that's what it looks like on the worksheet. So we are supposed to take 6.74 E2, or 10 to the second, giga-inches, and convert it to miles. Now I'm going to take this opportunity to tell you, don't try and make sense of any of the units that I'm going to give you here. You know, in terms of practicality, they are not. These are meant so I'm going to do my best to force you to touch every single metric prefix and every possible combination of different type of unit. So the issue isn't, do you know this stuff off the top of your head, but do you know how to work with the metric prefixes and the basic conversion factors that you should be able to, you know, have in your head. Okay, so one of the first decisions you have to make is, how do you get from giga-inches to miles? And different people can do this kind of through different pathways. But I think the first thing that most people would say is, I'm going to go from giga-inches to inches. And then I can go from inches to feet, because that's one that people are kind of familiar with. And then I can go feet to miles. Now somebody else might go, well, once I go to feet, maybe I'll go to meters, then I'd go to meters to kilometers, and then I could go kilometers to miles. That will work fine as well. It will involve more steps, but one of the things about your conversion problems is you can only do steps that you know the information for. You could tell me, oh, I could do this, but if, for example, you have forgotten or didn't bother to commit how many feet there are in a mile, then you can't do this, even though it's the quicker way of doing it. Okay, so here is the methodology that I want you to employ that you've probably seen before when you did stoichiometry in chemistry. So we start, I think I want to give myself plenty of room. So we start with our beginning value. We know in the end over here, we need to end up with miles. Okay, but in our first step, we said, I want to go between giga-inches and inches. Now this is where I have my terminology for doing this that is different from probably what you've seen before, and it's because of a story from my early years of teaching. You can ask me why I call it this. But it was passed on to me from another teacher. It was referred to as the magic H. Now the beauty about the magic H for me, and it kind of goes along with the railroad method, is that it gives you a numerator and a denominator structure. And if you recall from the long-winded methodologies that we did in the last 2 problems, one of the things that we came away from that with was if I want to convert this unit to another unit, that means I need this one to be canceled or to be done away with. And in order for that to happen, it has to go diagonal. And that means that unit would have to be placed here. Now, I can convert this to whatever I want as long as I know the conversion factor for it. Now, in this case, about the only thing that we could do with it is go to inches. Because if you said, well, I can go from giga-inches to meters and you could give me that number, that right conversion factor, you would definitely, I'm just going to say, you would be weird, okay? You'd make me nervous. Because that's not something that, you just walk around with off the top of your head. But this is a step here that only involves our metric prefix. Now, going back through our metric prefix methodology, giga has a multiplier of e to the 9, so I treat those exponents just like they're numbers on a number line. So I have giga at positive 9, and inch is like a base unit in the sense that it doesn't have a prefix, so that's a 0. So between these two, giga is bigger than the inch, so I put a 1 with the giga, and then I put the e to represent the base 10 on the opposite side, and the separation between 0 and 9 is 9. So this is my first step in my conversion process. Now, the nice thing about magic H's and the railroad method is you can just keep this thing going. In the other methodology that I showed you, you always have to stop and calculate something and then move on to the next step, and that's very, very time-consuming and a waste of space. This puts it all together and you kind of make it up as you go along. So we are not where we want to be yet at miles, but we're a little bit closer because we've gotten to inches. So what we need to do is create another magic H, and it's super easy to do. Now, at this moment, the only unit that I have is the inch, and I need it to go away, so I know that that has to go here, and I could put, again, I could go from inches to whatever unit I knew something about. I already decided we're going to go to feet. So we go feet there, inches are now canceled, so they go away. When we look at the relationship here, this is one that you would have memorized in your head. 1 foot is 12 inches. Making progress. Now we need to keep going, so that means I need another magic H. This time it's going to deal with my last step here between feet and meters, but I need feet to go away, so it needs to be diagonal to the feet that I have already established, and so it has to go diagonal. And again, I can convert this to whatever I need to, but if I remember my relationship, just to make this not too drawn out, if I remember the relationship, 1 mile is 5,280 feet. Now these feet cancel. There's the unit that I want on my answer. Now at this point, I have everything set up. The only thing left to do is a calculation. So in order to do the calculation, I can temporarily kind of ignore the units. I'm starting with this value, and now different people will process this in different ways, but this is the way I approach this, because there will be plenty of time where I see people get a wrong answer, and the only reason that you got the wrong answer, because you have the right structure set up, is that you did a mathematical error. I need to see what process did you go through to actually do the calculation. So in this case, I like to go one magic H at a time. There are other ways that you could go through this, and I'm going to leave that up to you, but if you are not getting the right answer, I may literally have to watch you punch keys on a calculator to make sure that you are putting it into the calculator the right way. Because you might have this perfectly correct, but you're having a mechanical calculation issue. So now that I have this set up, I start with this value. I look at my first magic H. I have a value over a 1, and that means I am multiplying at that point. Then I go over to the next magic H. I have a 1 over a value, and that tells me that I have to divide by the number that's in the denominator. Then I move over. I have a 1 over a value again, so that means divide. So this is the calculation that I actually need to be doing in order to get the right value. And if I do that, 6.74 E2 times E9 divide by 12 divide by 5,280, I get 1.064 E7 miles. Now on the worksheet, when you look at if you look at it, I give you this setup or this problem, and then off in parentheses, I'm actually giving you the answer so that you know whether you're getting it correct or not. And I'm just rounding my answers to 2 decimal places. So that's the number that you would see on the worksheet. If you had chosen a different pathway, maybe you had gone from feet to meters and then meters to kilometers and then kilometers to miles because that's what you needed to do, you might have a slightly different digit here at the end. You would still have the 1.0 and you would still have the E7. But not all conversion factors are exactly equal to each other. Okay, so this is the, I'll call it the simple way, shortcut way. I call it the magic H way. You might know it as the railroad method from chemistry, but this is what I want to see in your work when we go do one of these on a weekly basis for your quizzes. And very early on, we're going to jump on this because I don't want to waste any time going through this because this is a background skill that you should just know how to do. Okay, so there's one problem taken care of off of your worksheet. Now, I'm going to go ahead and do one more. And then, basically, our assignment is to do the other 8 to see if you get the hang of this. All right, so let's see. The other one that I would like to do is, I want to do something different. Let's look at number 4. All right, number 4, you have 3.8, I think it was 9, E3 okay. Now this one's gonna be a little bit quicker, and some of them will be pretty quickly. Will be pretty short because here all we need to do is get to gallon, and then we can go to liter. So instead of having 3 steps like we did last problem, this one's only going to require 2. So we start with our, sorry, that's E3. And this would be milligallons, and we want to get to liters. So the very first thing we need to do is get from milligallons to gallons, so we establish a magic H. And we need the unit of a milligallon to go away, so it has to go in the denominator, and we can change this to whatever we want, but we can just go to a gallon. Now this is one of our metric prefix situations here. Milli has a multiplier -3. Gallon is a base unit, would be 0. So the way that I approach this is I always like to put 1 on the bigger unit, and then I give the E to the smaller unit, and then when I look at how far apart are these two things on a number line, as long as I put a 1 with the bigger unit, the power of 10 will always be positive. So this cancels that, and now I can go from gallon. Again, I could go to whatever. If you don't remember the gallon to liter thing, and you remember a quart to liter thing, you might have to go from gallons to quarts and then quarts to liters. but this is one that I would think that you should commit to memory. 1 gallon is 3.78 liters. And with this structured this way, the gallons cancel and we're left with the liter as our surviving unit, so to speak. So when we go back and look at the math that we're doing, we would start with 3.89 E3. When we look at the first magic H, we have 1 over a value. So that means mathematically we would be dividing by this. And then when we move over to the next one, we have a number over 1, which means we would multiply by that at that spot. So we'd have 3.89 E3 divided by E3 times 3.78, and we get 1.47. If we went one more, we would show a 0, and this would be E1. And if you wanted to represent this as 14.70, I'm fine with that. On the worksheet, you would see 1.47 E1. Okay? So the big thing that I want you to get from this is how to set this up. Because if you set this up properly, the setup will tell you what math you should do. And as I mentioned earlier, I'm going to try my best to make you interact with all of the different units, all of the different metric prefixes. So in a way, if you get these things right, it's not because you have all these eclectic numbers memorized in your head and I just know to multiply by this or divide by this. It's because you can set this up. You can use a small number of relationships, conversion factor relationships, that allow you to put the right number in the right place, and then that setup tells you the math that you should do. And then, as I said earlier, down the road, when you've done this for most of your life and you're like, oh, I just know exactly what to do on my calculator, I don't need to write this down, that's fine. You've earned the right to do that. But at this point, if you get this kind of stuff wrong, it does not reflect really well on you in the science community, because this is kind of a base skill that you should be able to do. So your assignment now is to try the other 8 on the level 1 worksheet and then see how you do. And then what I'll be posting over, subsequently here is, well, what's different between a level 1 and a level 2 and a level 2 and a level 3? And I have a worksheet for each kind of bump up in difficulty, because this is as easy as it gets. And I do have to say one thing here, just to warn you. If you reflect back and you say, oh, this is just like stoichiometry, and I hear people coming in saying, what you do is you put what you don't want on the bottom and what you want on the top. That is technically incorrect. You will find that it will work for a level 1 because of the structure of the level 1 unit, but that rule or that approach will not always work. And the one word that you need to remember when it comes to all of this is diagonal. It just so happens that the diagonal will always go kind of like this in your setups for a level 1. But when we get to a level 2 and a level 3, the units that you start with will be more complex. And that idea that, well, put what you want to go away in the denominator, that does not always work. But remember that if you put things diagonal from each other, sometimes the diagonals go like this. But as we get to higher levels of difficulty, sometimes because the unit structure is a little more complex looking, the diagonal will go kind of in the opposite direction. So remember this word. That will be critical. All right, another half hour down. Good luck. If you have any questions on any of the problems, you can email me and we'll try and get you straightened out. All right, see you next time.